Software-defined storage as an enterprise solution is tricky because it's complicated and it's really mission critical. Now, to some extent, all storage is software-defined. Nobody sells you, maybe there's a few exceptions, but nobody sells you a raw box of disks and a cable and a power cord and says, go to it. All storage is software-defined. So what we're talking about here is taking that abstraction a step further and buying a layer of software that is uncoupled from specific vendor hardware. Although one of the things you need to consider is there will be a hardware compatibility list for any major software-defined storage product, and you better pay attention to it, because one of the risks is that industry standard is not necessarily industry standard. There are little incompatibilities introduced by different versions of firmware, BIOS, device drivers, what versions of software. So one complication, one factor for selecting software-defined storage is you need to understand if it's compatible with your infrastructure. The odds are good that you're going to be okay, but you need to think about it. A much more significant question is, does it have the functions you need at the acceptable levels of performance and acceptable SLAs? Because on paper, most of these products look excellent. As I talk with clients who are actually implementing them, we hear very specific comments that this vendor has all the functions, but latency is a problem. And I've heard, for example, several really, really well-known software-defined storage products have come in for criticism about latency, specifically latency, as they go between cloud and enterprise. Now, that may not be a problem for some applications, but it's your responsibility as a user to know that ahead of time. So the whole functionality bit, does it have the services you need? What kind of data protection, what kind of backup disaster recovery assists, even down to a level of runtime efficiency versus space efficiency and how it protects data. Some solutions run really, really fast, but the most efficient way to protect data from a runtime perspective is to do replication, sharded replication, which if you've got a handful of terabytes, that's okay. But if you're talking petabytes, having 2 or 3 replicates of that data distributed around the enterprise, not so good. On the other hand, erasure coding, which is mathematically very efficient from a storage perspective, can have a runtime penalty if it's not done right. Then you need to do cost analysis, and that's tricky, because cost analysis needs to include both the software, the hardware, the changes to your operation based on switching to this environment, and you need to sort of factor in the cost of switching your storage architecture. And most people do not do a wholesale rip and replace. They bring in software-defined storage for one set, net new projects, and over time they'll continue to migrate workloads to that. And as I've said in other venues, the consumption of hyperconverged storage is kind of a Trojan horse for software-defined storage, because that is in effect what it does. And increasingly, the hyperconverged solution vendors have unbundled their solutions from the underlying hardware. So even the companies that sell an appliance will also be selling that software to sit on top of third-party hardware.